Assalamualaikum warahmatullahi wabarakatuh.
Recording in progress.
Good afternoon, ladies and gentlemen. I hope you had a nice break. For this time, we meet again to next event of agenda. Before we start to next agenda, please, to all of buddies, make sure your participants already on the Zoom meet because our next lecture is in a minute. Is everyone already in Zoom meet yet, to buddies? How? Already? Okay. Our second lecture will be presented by Andreas Ardian Wijaya STMT, accompanied by the moderator for Bapak Andreas Ardian Wijaya STMT and a moderator. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asrafil anbiya wal mursalin Sayyidina Muhammadin wa ala alihi washabihi ajma'in, amma ba'du. Good day to all of the participants. First of all, let me introduce myself. My name Abdurrahim. It's an honor for me today to be the moderator for the lecture 2. Lecture 2 has entitled of Soil Improvement for Liquefaction Mitigation, will be delivered by Mr. Andreas Ardian Wijaya. Maybe it's not very known for the participant for the what is liquefaction. Nowadays we know that from the news that earthquake that hit Turkey, we can see clearly for the from the media, as visually we can see that what happened when the quake hit an area. But actually the result of earthquake is not only what we see now, the rupture of building, not only that. We can see also from the field that it's also a phenomenon we call it liquefaction. So I think from this afternoon, it's very interesting to know more about what is liquefaction. What is happen in the field, which is called liquefaction. In this afternoon, Pak Andreas Ardian Wijaya will give you what is liquefaction. Okay, but before that, I will introduce first for our speaker this afternoon, Mr. Andreas Ardian Wijaya. He completed the bachelor program and also the magister program in civil engineering in Universitas Katolik Pariangan in Indonesia. Pak Ardian, we call it Pak Ardian, the nickname Pak Ardian, is very active in Indonesian Society for Geotechnical Engineering. And from last to now, Pak Ardian has many projects in the geotechnical work. So I will give the time for Pak Erdian to explain what is the liquefaction. So I hope this lecture it's interested for all of the participants. So time I give to Pak Erdian. Thank you.
Okay, thank you, Pak Abdul Rahim. Good afternoon, everyone. Is my presentation slide can be seen, Pak?
Jelas Pak?
Okay, yeah. Good afternoon, everyone. Thanks, Pak Abdul Rahim and all the committee that allow me to give sharing and discussion today in this afternoon. I will give a sharing about soil improvement for liquefaction mitigation. So as Pak Rohim already explained, me myself, I have worked for soil improvement company named PT Geotech Indo in Indonesia, and internationally we are known as we are known as Geo Harbor Shanghai Construction Group. Okay, in today's discussion, first I would like to introduce first about the liquefaction phenomena. What is it? What causes it? And then after that, I will share some of the method, the engineering method we can apply to strengthen our soil. So when the earthquake comes, the liquefaction will not damaging our structure or our infrastructure. To begin this presentation, first of all, I would like to share a video first about the liquefaction. Okay, wait a moment. Sorry, there is some error here. Okay. So in this video, there is an experiment, the simulation of liquefaction made by a professor in Japan. Here he made three house model, simple model, the house that built above a strip foundation, a rough foundation, and using a pile foundation. Then during this experiment, he will shake the soil. This is the granular soil that is saturated, loose granular soil that is saturated. Then he simulate the earthquake. As you can see at the beginning of earthquake, there is seems like nothing happened. It's okay, but suddenly at some point when the earthquake is strong enough, the soil will suddenly liquefy, and some of the object can be sunk into the ground like this. And for the house that is not properly built with a strong foundation, damage will occur in the house like this. This is the phenomenon known as liquefaction. This is the engineering term about liquefaction. I will just briefly introduce it. You can see from this picture, like this is what really happened in Christchurch 2011 when the earthquake came and the liquefaction happened. So during the liquefaction, when the shaking happened, pore water pressure between the soil will generate excess pressure. Then, as you know, when the water pressure is generated, it will try to find a way to out. Then when the water coming out, the granular particle will rearrange itself to a more denser state like this. So the granular, when earthquake happen, will get loose first, and then it will get closer together. So there will be some settlement happen in the surface and water will flow to the surface. Liquefaction can be identified with several forms. For example, the first form is sand blow. Sand blow will happen like this. So there at a certain point, there will be a sand boiling from underneath ground. So this is happen when there is a sediment layer that is unliquefied. above the liquefied layer like this layer. So the top layer may be clay or silt that is not liquefied. So when the earthquake comes, the pore water pressure is strong enough to penetrate through the liquefied layer, and it will cause damage on the surface. And also at some angle or slope area, when the liquefaction happen, it could cause something like lateral spreading like this, or flow liquefaction like what happened in Palu Donggala like this. So first about after we talk about what is liquefaction, then we need to assess when we have a project, whether it's a structure or infrastructural project, we need to evaluate our project. Then from certain criteria, we can determine whether this soil is prone to liquefaction or it's okay that the soil is not liquefiable during the earthquake. There is 4 criteria need to be fulfilled in order to us can say that this soil is liquefiable. If one of these criteria is not met, then the soil is not liquefiable. The first criteria will be a historical criteria. So basically, when we have a project, we will first gather earthquake data. For example, I have a project in Jakarta, then we try to gather the data from USGS. This is a free website. We can collect earthquake data from long time ago. Then, as you can see, this is the top 15 earthquake that ever happened in Jakarta. But actually, I collect more than 1,000 earthquake happen here. So usually we will plot the earthquake through this chart. This is the chart of epicenter distance and the magnitude of earthquake. This chart is telling us that if the point is in the left side of the chart, means that it will cause damage during liquefaction. However, if the point is in the right side, it will not cause liquefaction. So historical criteria means that if one or several earthquake ever located in the left side of the chart, it means that this project is potentially have a liquefaction. So we need to check the other criteria. You can see here that when I collect like top 15 earthquake ever happened to Jakarta, the biggest actually is 7.7 magnitude. However, the 7.7 happened quite far away from Jakarta city center. That is why this 7.7 and 7.6 earthquake does not cause liquefaction. The only earthquake that caused liquefaction is the one happened in 2007. That happened quite close to Jakarta, so it can potentially cause liquefaction in some of Jakarta soil. The next criteria will be the geological criteria. So in this criteria, basically what is said is that the soil that can prone to liquefaction is a soil that is deposit like this, like from a river, from a erode debris, from a wind, or a man-made hydraulic field. So in our project, a lot of reclamation project, especially, usually we will do the hydraulic field. Hydraulic field is like when we dredge sand, we will mix the sand with water, then we will pump the field with water and sand through the reclamation area. With this method, when we check the dredging, when we check the filling point, the filling point will tend to have a larger particle size, because when we do the dredging, the hydraulic field, some of the large particle will deposit first. Because it's heavy, it will deposit first, and the smallest particle will flow away. So by doing the hydraulic field, usually we will have first an ununiform grain size, because the particle with same size will deposit around the same area, and then the soil will deposit in a loose state, because when it deposit, it's have water in it and it was not compacted. So this is the type of soil that is geological criteria fulfill that it's prone to liquefaction. And the second criteria is, the third criteria is compositional criteria. So from this, we can plot the grain size distribution of our soil to check whether it's in between the boundary of most liquefiable soil or in the boundary of potentially liquefied soil. Usually when people talk about liquefaction, they say that only sand, saturated sand will liquefy. However, if we are check these compositional criteria, we can say that actually silt also is liquefiable. So when we have a saturated silt in the project, we need to be careful and find whether the silt is really prone to liquefaction or no. And the last criteria, the one we will talk most, is about the stat criteria. This is one of the criteria that we can modify, we can engineer it, so we can we can design something to make our project not liquefied able. In the stat criteria, basically it's like this. There is two things we need to check during earthquake. First is the resistance of our soil. It's called cyclic shear stress, CSRR. And then the second is the cyclic stress that happen due to earthquake. So we calculate two things. First is the resistance of soil, the blue line, and then the stress that caused by the earthquake, the red line. So if at certain depth, the stress is lower than the resistance, it's okay. The soil will not liquefy. However, at some depth, when the stress of earthquake is bigger than our resistance, this is the layer that is liquefied, and we need to do something to increase the resistance of soil or to reduce the stress of earthquake, the shear stress of earthquake. So the liquefaction will not happen in this area. This is the typical Excel spreadsheet that we use to calculate the factor of safety through the liquefaction. I will briefly explain about this chart because we will back to this Excel chart several times throughout the discussion. First, when we do the evaluation for liquefaction, we need to know the earthquake data first, like the magnitude of the earthquake and the peak ground acceleration, the aim of the earthquake. Then we can determine what is our minimum factor of safety we want to take into account in this project. For example, usually it's 1.1. Then we can input our soil data, the fine content. First, we will calculate the cyclic stress ratio. So basically here, we try to find the CSR for every depth. After we get from the earthquake data, we can calculate the stress happen. Then next is we calculate the resistance of soil. So from the SPT value and the fine content, we can then calculate all of these. And at the end, we will get the CRR or the resistance of soil. By comparing these two, then we can find the factor of safety for liquefaction. As you can see here, from 1 to 12 meter, the soil is subjected to liquefaction. So we need to do something to increase the strength of the soil. Then, beside the factor of safety, we also can determine the LPI or the liquefaction potential index. Basically, from this LPI, then we can categorize our project have a very high, like this chart from Iwasaki, 1982. Is it a very low liquefaction potential or have a high liquefaction potential, etc. Also from the same chart, what we can do is if we play with it, we can back analysis and we can calculate the minimum SPT that can resulting the factor of safety of 1.1. If we do like that, then we can back calculate and we can get this value. This is the minimum value for the soil in order to, we can say that it's already safe from liquefaction. We will back to this later. So after we are discussing about the CRR, basically we will jump into soil improvement now. Basically, soil improvement for liquefaction mitigation, it's can be categorized as three criteria. First, what we can do is we can increase the soil resistance. So we are increasing the CRR, or we can reduce the earthquake cyclic stress ratio. So when the earthquake comes, we try to absorb some of the earthquake force. So what have been transferred to the soil will be reduced. So we will reduce the CSR. And third is if we can provide the drainage, so when the liquefaction happen, the excess pore water pressure will have a place to dissipate. For example, if we are making a drain or we're making a stone column to let the excess pore water pressure to be released. Soil improvement method actually is quite a lot, but today we will focus on first about the compaction method. In compaction method, we will increase the resistance of soil. So we will make our soil stiffer and can resist more stress during earthquake. Or we can create something underneath ground like grouting or mixing. So we try to absorb some of the earthquake stress to the mixing material, or we can do some inclusion. First, I want to share about dynamic compaction. So in the compaction method of soil improvement, we have two options to compact the loose granular material. First is with dynamic compaction, and second is with fibro compaction. So in dynamic compaction, what we do is basically like this illustration. We will drop a hammer or a tamper with a certain weight at a certain height. We can calculate it first. Then we will try to compact the soil by dropping the weight like this, by impacting the loose granular soil. After the first phase, we will continue with the second. We will fill the crater first, and we will continue to the second phase like this. We will do the tamping in between the first phase, and also we will continue with the third phase to cover overall area. This is one of our project. We are doing the dynamic compaction in Yogyakarta International Airport. Usually this method is very effective when the treatment depth is less than 6 meters. The dynamic compaction have the limitation of depth because when we do the tamping like this, the energy will be dissipated throughout that. So with a certain height and weight, we only can improve the soil until certain depth. And in Indonesia, for now, looks like the effective way is just to improve until 6 or 8 meters with dynamic compaction. If it's more than 6 meters, then we're gonna need to do another method called fibro compaction. This is the photo from the Yogyakarta International Airport project where we do the dynamic compaction. At this project, the soil is a loose sand that is very clean with a fine content less than 6. So it's very suitable for dynamic compaction, and the loose soil is only at the top 6 meters. From the project, the consultant do the evaluation of liquefaction, then they can determine this chart. This is the minimum SPT value like the one we have calculated earlier. So they have back analysis it with a earthquake in that region. This is the minimum SPT need to be reached in order to make the airport safe from liquefaction. Then after this target has been determined, we do the trial on site we do some soil investigation with CPT before improvement, and then we do another after the improvement. So we can check whether it's already in the right side of the target or no. We can do both for CPT and SPT. This is the photo. And for the second method of compaction, we can do fibro flotation. Basically, fibro flotation method is like this. So we have a vibrating tube with a water jetting. We will try to vibrate the loose granular material to make it compact. What we do here is actually like we are creating a small and controlled liquefaction. We try to vibrate the granular material. We are jetting some water to increase the excess pore water pressure. So when we lift the probe, it will be compacted. Yeah, this method can improve soil with depth more than 6 meters, obviously. I will skip this. This is some photo of our project using the fibro flotation method. Same with the dynamic compaction. Usually they will calculate first the minimum criteria for the QC and SPT. Before we do the improvement, we will check with the CPT, and after improvement, we will check also with another CPT. One of the project that using this method is the extension of apron in Ngurah Rai International Airport. We have do the project in July 2020. This is the photo where the fibro flotation happened. Yeah, now already completed like this. Okay, the next method we want to share here is mixing and routing. So when the liquefaction happen, we can try to absorb the shear stress by creating something underneath ground. That something can be in form of pile or in form of deep mixing in this case. Deep mixing can be created with a mechanical auger. We call it deep cement mixing or deep soil mixing. Or we can mix the soil using a jetting power. So usually this method is called jet grouting. This is more common and typical method, may be well known. For the deep cement mixing, we can create a lot of pattern because of the installation method. And the most typical method for liquefaction mitigation is the box, because when we try to confine the loose granular material in a box, when the liquefaction happen, the soil will trap inside this box, and the liquefaction will be more easily to control. Okay, deep mixing method is constructed by the method like this. So basically, we will have an equipment with a mixing auger underneath, and we will try to mix with auger the soil. First, we will try to blend the in situ soil first, and then when it reach penetration depth, we will try to pump a cement slurry. Then we will mix it while pulling up the auger. This is the photo of deep cement mixing equipment, and this is the result. You can see here, this is the deep mixing box, and this inside is a granular soil that is prone to liquefaction. So when the earthquake comes, a lot of the earthquake force will be taken by this element, the stiffer element. Then some of the earthquake force will be generated in the soil. It's more little, so from the calculation, it's shown that it's already okay and will not liquefy during the earthquake in this region. This is a project from Matarbari project. And this is the arrangement of deep cement mixing. They have tried to calculate and design several patterns, and for the optimize of the design in the middle part where they didn't need much force, they can make the replacement ratio more less. Okay, when we are designing for the liquefaction using the reduction of CSR method, what we can do here is that with the same analysis, then we can calculate, we can here specify, we try to design our pile, then we can determine the shear modulus of our material. Then from here, there is a formula from bias. We can calculate the new CSR value. So basically, the new CSR value will be less than the value from the previous. Then after that, we can determine the new factor of safety. And we in this case, for example, with a 0.7 diameter DZM in a spacing of 2.5 in a square pattern, we are able to reach all depth will not be liquefied. This is the example of how we design with DCM for liquefaction. For the DCM parameter, there is a lot of reference out there we can take. And next, I want to discuss about the inclusion method of soil improvement. In the inclusion method, basically, if we are talking about the liquefaction, it's the best if we can use stone column, because you know why? Because in stone column, during the installation, we can choose the vibrating method. So during the installation, because we are vibrating to create the stone column, the sand around the installation of stone column will be also compacted, because we are not boring and taking out the soil. We just displacing and vibrating the granular material, so it will be denser after we install stone column. At the other hand, we're also creating a gravel column or a stone column. So when the earthquake comes, some of the earthquake force will be absorbed by this gravel. And third, by using stone column, when the earthquake comes, when the excess pore water pressure develops, it can flow to the stone column, because stone column is granular material and it can act as drainage also. So with stone column, we can do three method at the same time. Okay, in inclusion method, to create stone column, actually we have a lot of option. We have a lot of construction method. Here I highlight some method that is suitable if we are having a project with liquefaction. For example, using fibro replacement. So in fibro replacement, this is actually the same equipment with the fibro flotation, the one I have shown earlier. However, during the installation, we will try to fit gravel from above. So when we vibrate, later the gravel will be compacted, and will, at the end of the construction, we will have a stone column. This is the fibro replacement method to create stone column. Or we can do the compaction column, where there is a top mounted vibrator. Means that in this method, we will compact the stone column by vibrating it up and down, like a pencil, like a driven pile. But basically in this method, we will pushing down the stone column. This will also create vibration, and the soil between stone column will be also compacted. And last method, this method is called deep dynamic compaction. This is almost same with dynamic compaction, the equipment. However, when we do the tamping, we will try to build a well. We will fill with gravel, then we compact by dropping a hammer into the well. Okay, this is the stone column method that using the fibro flotation equipment. So you can see this is the same equipment. We can penetrate this to the ground, and then after, during the penetration, we will fill from above with a gravel material. So when we lift the prop, the gravel will be full, and we can repeat this step until it reaches the top layer. This is one of our project in TPA Sidoarjo. Oh, by the way, for stone column now in Indonesia, we already have the national code. For this one, we call it type B. And for the dry method, we call it type C. In the stone column dry method, the equipment look like this. This is the top mounted vibrator. Yeah, this is the equipment. So we can fill the gravel to this steel tube. Then during the installation, it will look like this. This is the fibro hammer. At the end, it have a one-way valve, meaning that when we do the penetration with this tube, the soil cannot get in. However, when we lift the probe, then the gravel will discharge from the end of this tube. So first we will vibrate and insert the tube. During the installation, around the stone column will be also vibrated and compacted. Then we will fill the gravel to the tube. Then when we pull out the tube, some of the gravel will be discharged, and then we can repenetrate the stone column to make the gravel compacted. Then we can repeat this step over and over again until reach the design depth. This is the dry method stone column. One of our project that are using this is in Doho Kediri. Yeah, this is the stone column. Or in the Soekarno-Hatta International Airport, we also have a stone column there for the sand layer at the top part, 8 meter. I want to show here is one of our trial installation in Soekarno-Hatta. So at that time, we do the trial with arrangement of 3 columns like this. This 1, 2, 3. And before the installation, we test in the middle with the CPT and SPT. And after the installation, we repeat again at the same point. Around the same point, we do the CPT and SPT to check is something happen or is the properties of the sand in the farthest point have increased due to the installation process. And here is the result. Okay, in the left side is the SPT before, and in the right side is the SPT after. For the soil layer, you can see here have a sand, have a clay, and another sand, another clay. So if I make a summary like this is the value of before improvement, and this is the value of after improvement. We can see clearly here that for the clay, the SPT value almost no change. The fat clay below also. However, for the sandy layer, the SPT value has been increased, meaning that the granular soil has been compacted during the installation process. Same value has been observed using the CPTU data. You can see before and after improvement, there is an increment of con resistance. When we are doing the design for stone column for mitigation liquefaction, we can do first is same with DCM. We can design the stone column. We input the shear modulus of stone column. Then we can reduce the cyclic stress ratio. But due to the increment of SPT value, we can now change the SPT to the improved value. And then we can get the increment of resistance. So we can get these two value. However, what limited in stone column method is that the shear modulus of gravel is obviously will be less than in concrete material or in deep cement mixing material. The last is about the drain the stone column using drainage approach to mitigate liquefaction. Basically, I will not go into deep for this topic. I take this presentation from Professor Juan Pestana. Basically, the concept is like when we are calculate the stone column for liquefaction mitigation using drainage approach, we need to do the dynamic analysis in software. Usually with final element or other software, we try to create the cycle of earthquake. We simulate it in the software. Then we check the excess pore water pressure ratio. Then we limit the pore pressure ratio to certain value. So the approach is like when you have a stone column or a drain during earthquake, the excess water pressure will generate due to the earthquake and will dissipate also at the same time because we have a drainage in stone column, and we can get this kind of value. The last method I want to share here for the soil improvement is by using rigid inclusion. So this method actually looks a lot like stone column method. The only difference, you can notice that the equipment actually is same. The only difference is that instead of feeding this material with stone, we will fill this tube with a low-grade concrete. So same installation method. However, if we are able to use concrete for the feeding material, the shear modulus of concrete will be much more stiff compared with the stone column. Means that when the earthquake comes, it can absorb more of the earthquake force theoretically. So this method actually is known with a lot of names out there, but basically this is a same method that usually called rigid inclusion. Yeah. For feeding with concrete, we have two options actually. Beside using the vibrating tube like this one, we also can use continuous flat auger or CFA. So in this method, we will do the installation by first using the long screw. We will screw the soil. Then after it reach a design depth, we will slowly pulling the screw up while pumping the concrete. For rigid inclusion, even though it looks like a pile, this have a very distinguished behavior with pile. And usually for rigid inclusion, we didn't put any reinforcement. So this is just a low grade or medium grade concrete without any reinforcement. Yeah, this is the end product of the rigid inclusion. So you can see this column is a lot more stiffer compared with the stone column or even with the deep cement column. We can test the column to check the elastic modulus and etc. Okay, I think that's all the presentation and the sharing from me about soil improvement for liquefaction mitigation. I hope it's you can get something from this presentation. Thanks once again. I give it back to Pak Rohim.
Yeah. Thank you very much, Pak Erdian, for the interesting presentation. So it's time to question and answer. Is there any question for the participant? Okay, to all the participants, you can also ask Erdian directly if you want. Okay, the first question, Pak Erdian. Is there any difference in efficiency between the stone method of dry method and wet method? And when should we use the wet method and dry method?
Oh, okay. I directly answer, Pak. So for the difference between stone column dry method and wet method, usually it's depend on the project location first, whether the water source is available or no. And second is the diameter of the stone column. So for the dry method, usually we only able to construct the stone column with a diameter around 50 or maybe 60 centimeter. However, with a wet method, because we are doing the vibration, we can fill a lot much stone to it. We can create like 1 or 1.2 diameter of stone column. So it depends on the design, depend on the water resource. But in terms of efficiency in design point of view, it will be not much of a different. In my understanding, it's like that. Is that answer your question, Pak Muhammad Faris?
Okay. Next question, Pak Erdian. Are all the method applicable for all type of soil? Or is there a specific method for specific type of soil?
Okay, maybe I was too quick. Let me go back to the presentation file a moment. Okay, Pak. So basically, to determine what kind of soil improvement, we need to differentiate it first with the soil type. For example, dynamic compaction and fibro compaction is only applicable for a sand and a gravel material. It cannot be applied on clay. So not all soil improvement method can be used for all type of soil. If we are having a clay and silt, then usually we will need to do improvement with a consolidation approach. It will be using the PVD, using a preloading. This will be a different type of soil improvement. And for the clay and silt, because it's not a subject of liquefaction in today's discussion, we didn't talk about it. However, for the deep cement mixing or for the rigid inclusion, actually, yes, this is applicable for most type of soil. The only different in design is usually we are checking which one is more cost effective, and in terms of time, which one is still fit in the project schedule. For growing and mixing, it has some limitation because we are mixing the soil using a blade or a auger blade. If the soil SPT is too high, then it will not be able to penetrate. But for growing, mixing, and inclusion in general, it applicable for the most type of soil. In terms of cost, usually the compaction method and consolidation will be cheaper because in these two methods, this is physical approach. We didn't introduce any material to the ground. In the growing and mixing or inclusion, we need to bring something from outside and we need to construct something underneath the ground. So usually it will be more expensive.
Thank you, sir.
Yeah, thank you.
Any question? Okay. Pak Ardian,
Yeah, Pak.
this question from me, Pak. You mentioned a lot of soil improvement for liquefaction. I think it is all in order to increase the stiffness of soil. But the question is from a lot of soil improvement, which one is most or the cheapest one, and is it need requirement for any type of soil improvement? So I think because we don't know which one is suitable for a location. Thank you, Pak.
Yeah, Pak. For liquefaction mitigation, actually the cheapest method is using dynamic compaction, Pak. Because this method we didn't introduce anything and it's quite simple. We just dropping and tamping the granular soil with certain height and weight. However, this method have a limitation of the improvement depth and the kind of soil. I mean that like these two methods only applicable if the granular material have a fine content less than around 12%. If the fine content is too high, then maybe this two method will not able to compact the soil to a certain required SPT or QC. So when it happened, so we didn't have any more, we cannot use this method. Then we move to the next method like deep cement mixing or stone column or rigid inclusion. Usually the project that need soil improvement is an infrastructure project. So if only a structural project for liquefaction, it still can be managed by designing the correct pile foundation. So when the liquefaction happen, the structure will be safe and will stand through the earthquake. However, for the like this example, for the parking lot, for the road, maybe will be damaged due to liquefaction. That is why sometimes beside designing the pile foundation, some owner or government for the infrastructure development, they will consider to do soil improvement instead of using pile for all over the area. It will be more expensive to use pile foundation in such case, Pak. I hope that answer your question, Pak.
Okay. Thank you, Pak Erdian. Any question? No? Okay. Pak Erdian,
Ya, Pak.
nowadays in Turkey is hit by the earthquake. Is there any liquefaction in Turkey, Pak?
Yeah, Pak. Unfortunately, I have not get any data or known update about the Turkey liquefaction phenomenon yet, Pak.
Okay. 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 Next question from Nisa. So, time is yours.
Oh,
Check, thank you. So, Mr. Adrian, can I ask you about the grading method? Like, we need to edit the materials to improve the soil bearing capacity, right? Is it possible to like renew the material, like we use polyethylene, for example, or a plastic bag? Because I see in a lot of construction for transportation for road, like they're trying to use a plastic bag or polyethylene to improve their capability to resist the water or something like that. Is it possible for a building like high building or in a depth? Apa ya? Like we know that what you are explaining is for mainly for a building, but is it possible to use polyethylene for grouting? Thank you.
I'm sorry, I didn't get it clearly. What is the material again?
Polyethylene or plastic bag?
Oh, plastic bag.
Yes.
Okay, so in order to be able to fit through the dynamic deep cement mixing equipment, we need the material can be diluted in a slurry. Looks like that if that material can be diluted, then it's okay. It can be mixed with the soil in situ. But we need to do the trial mixing first to check what kind of strength it can reach and will it stay for a long term or just a temporary. That one need to be answered by the trial mix, I think. But it's possible, I think. It can open up a lot of new research using that topic. Very good question.
Thank you. I think I just find my topic for my tugas. Thank you.
Yeah, as long as it can.
Okay. Next question. I think it's from Malaysia. Naili Ukraina binti Nikrosti. Does all the method have a specific range of depth?
Specific. Oh, okay. So for the depth of improvement, usually like this. For all for our project that's subjected to liquefaction, usually we only consider the top 15 or top 20 meter. This is the depth that is usually in a range of improvement for liquefaction. Below the 20 meter, it usually ignored because we from the calculation, the overburden is big enough to cause no damage during the liquefied of below 20 meter depth. So 20 meter will be the maximum. However, if you are asking about the soil improvement, not for liquefaction, the depth of improvement will be determined by the equipment. So if you need the deeper improvement, we need to check the equipment capacity. For example, for stone column, maybe 35 meter still achievable with a big or a special equipment. Or for deep cement mixing, for the typical equipment, it will be 20 meter, but for the big equipment, it can go up to 40 meter also. I hope that answer your question, Ibu Rosdi.
Okay. Yeah. Next question from Siti Nur Hawiza Ahmad. How we know soil method that in construction or in lab?
Oh,
How do we know?
sorry, Pak, I still didn't get the
Yeah.
question right.
How
How
do we know soil method that?
how
Okay. So I think the question is asking about what have you mentioned in the presentation is in construction or in a lab. I think it's very clearly that all the soil improvement that you said in the presentation is in the construction.
Oh yeah, in the
Yeah.
site construction, correct?
Yeah.
Yeah.
Maybe for in the lab, Pak Ardian, how can we bring the field into the lab, Pak?
Actually, Pak, for every site project, almost all of them we have a trial before the real construction. During the trial, we will do a lot of tests, including lab tests, especially for deep cement mixing. Because for deep cement mixing, we need to determine the cement content first, like how many percent of cement or how many kilogram of cement need to be mixed for one pile. That will be found in a lab. We will bring the soil. We also bring the water from the in situ location. So we mix the in situ soil, in situ water with the, for example, cement content of 10%, 15%, and 20. Then we can get the compressive strength of 28T for each sample. We will also do that. And if we want to change the cement material with other polymer or other binding agent, also possible. Also, we can try to use cement additive or etc. during this lab testing. After that, we will do the trial installation on site. Then after 28 days, the deep cement mixing, we will also do the coring, and we will bring the material to the lab again to check the compressive strength. That is usually what we do. So it's not only the site construction, we will also do some lab tests for it.
Yeah. Pak Ardian, talking
Yeah.
about the earthquake motion. So how do we know that the shaking of earthquake we use in the lab is correct or not, or represented in the field reality, Pak?
For the dynamic lab, we have not done it yet, Pak. Unfortunately, we have never used it yet in Indonesia.
Okay.
We only
Next.
test the soil improvement material, but we haven't do any model like shaking table or.
Yeah. Because actually Pak Erdian is also happen to our student that when they want to study about the earthquake, actually for the soil, so we just use shaking table, but we don't know exactly for the shake, Pak. Is it correct or not, gitu, Pak?
Hmm.
Yeah.
Yeah, understood.
Next
It's
question,
very hard.
Pak. Yeah, next question, Pak.
Okay. Okay.
From Otto Iskandar from Indonesia, there is side effect for doing soil improvement and how to deal with it.
Okay. When we talk about side effect of soil improvement, we need to discuss which method you mean here first. For example, for dynamic compaction, because we are doing the heavy tamping, we will have a noise around the project area and we will have a vibration. So what we can do is first we check around the construction area. Is there any nearby uh, people that live around the project area? If have dynamic compaction, usually will not be allowed. And second, for the vibration, if we have an existing structure nearby the construction area, we will do the trial tamping, and we can monitor the peak particle velocity. There is an equipment to check the vibration. If the vibration is strong enough to cause a damage, then we will move the soil improvement boundary, meaning that there is some area will not be improved at that project. That is for dynamic compaction, the most method that cause disturbance to the surrounding. However, for other method like stone column, deep cement mixing, it will also affect the surrounding, but usually it will only like 10 or 5 meters, so it's still okay.
Okay. Bardian, talking about the dynamic compaction, from your experience, what is the minimum distance from the location to the settlement of people?
Oh, if we are talking about vibration, but actually 25 to 30 meter will be safe.
Okay.
If we are talking about vibration. However, if we are talking about noise, it will be depend on how the settlement around the project able to tolerate it. At some project, we are still doing the dynamic compaction nearby the settlement, but we only do it at day shift, of course, at night. After 4 p.m., we will not do anything, and before 8 p.m., we cannot do anything also.
Oh, I see. Okay.
Yeah,
Only 25 to 30 meters is
30
okay, Pak.
meter. Yeah.
Okay, I see. Okay. Next question from John Patrick Mitran. How long or how many years do soil improvement last?
How long, how many years does soil improvement last? This is not talking about the construction period, right? This is about the quality. How long?
No, I think
The,
in
yeah,
the real field, Pak, for the what the the soil improvement itself is takes how many maybe how many months or
okay, okay, Pak. So, for the soil improvement project, usually we have several months until 1 year to do the construction before they build anything above it. However, if you are asking about the performance, like after the construction, how many years it will long, actually it will stay for quite long time. At some project, usually the owner will ask a guarantee for some project, ask for 10 years, and there is several project also asking 20 years guarantee, because during soil improvement, usually we are not do the improvement for liquefaction only, but we also doing it for post settlement. in a post-settlement project, usually the owner will want the guarantee or the warranty until like 10 years or 20 years. But if for the bearing capacity or liquefaction, usually they didn't ask for such thing. But when it's there, I think it will be there for a quite long time along the project.
Okay, thank you, Pak Erdian. I think we okay. We only have 1 minute left, so I give to Pak Erdian for final remark, Pak.
Okay. For the final remark in this sharing session, I think is that liquefaction is a phenomena that will happen for most of our project if we are sitting around the earthquake seismic active zone. So we cannot ignore that phenomena. We need to assess when we have a project, we need to assess that, and then we need to determine whether this project need to do something or we can really ignore the potential, the hazard of liquefaction. To do the improvement, there is a lot of option to ensure the safety of the structure that we as a civil engineer build. I think that is our closing remark for this sharing session. Thank you all for the interactive question and answer, and for Pak Rohim, the opportunity for me to give this sharing part.
Okay.
Thank you,
Thanks.
sir.
Okay. Thank you, Pak Erdian, for the interesting presentation. So I think it's time to me to leave, and I give to another speakers, Floris Bugart, to join us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Our deepest gratitude for Mr. Andreas and Mr. Abdurrahim, who has bringing sharing new knowledge several and about soil improvement and several method of that. Thank you.
Here we come to the last lecture of the day about recent technology on water management in Netherlands by Professor Floris Bogart and the moderator Mr. Ari Sentani, ST MSG. Please welcome to the Professor Floris Bogart and Mr. Ari Sentani, ST MSG as moderator. Time is yours.
Okay, thank you for the opportunity from both of you, the MC. Good afternoon, of all. Hello, Floris. Could you hear me clearly?
Yes, yes, loud and clear. You hear me as well?
Okay. I will introduce Prof. Floris. Prof. Floris accepted a professional special transformation at the School of Architecture, Built Environment and Civil Engineering at Hans University of Applied Science in Groningen in 2030, working on urban climate adaptation around the world in close relation with other universities. Professor Floris Bogart has over 25 years experience in research and consultancy in international climate adaptation. And now he will introduce, or maybe with all of his experience about the water management, he will introduce you of all of the participants of RMI about the water, because we have a lot of problem with the water, especially in Asia, and we will have more problems maybe during next 20 years. The problem of water can touch our global life, including personal security, economic growth, political stability, and interstate conflict. And now, Prof. Floris Bogart, the time is yours.
Thank you so much. And yeah, thanks for the invite, of course. It's great to see so so many familiar faces as well. So I'm gonna share my screen, and I hope it all turns out for the best. Share, so I hope you will see my full screen soon. Yeah, it's happening. It should be good. Otherwise, tell me. So yes, thanks again for the fine introduction. Recent technology on water management in the Netherlands. Of course, I would like to speak also about other countries. Most of you are in Asia, so I also have some practicalities that you could use for your practice as well. So maybe as a small introduction, a lot has been said, but basically I am a professor in the Northeast Netherlands in Groningen. I'm also an affiliate researcher at the Global Center of Adaptation, which I will tell something more about. And I'm also a consultant at a research agency, Deltares, that does a lot of work around the world. And why do I have three jobs? Basically, to form an alliance between education, research, and professional practice, because that's what I believe. One of the conclusions of this is we really have to work together. We have to prove things with research. We have to raise awareness with education. We have to do closely work with practice, of course, to get our solutions. So these jobs are in Rotterdam and in Groningen, for example, they're below sea level. And that's something I want to address as well. A lot of regions in the world are below sea level or will be below sea level because of sea level rise or subsidence. Maybe just to brush on where I come from, Deltares Research Institute does a lot of work around the world. Cities, one of the things I will address, and of course flood management, but also about water quality and livelihoods in cities. Then I'm a professor at Groningen, so doing a research, my research group, some pictures up here, a lot of international projects as in Indonesia, Philippines, but also New Orleans, Vancouver, so basically around the world as well. And the GCA Global Solution Brokering, want a solution, we can help you out and find other cities or countries that have the same problem there you can benefit from. And maybe just one, because it's really about applied science. So I gather best management practices about water and climate adaptation. Well, this is the head office of Global Center of Adaptation. I'm in Rotterdam. As you can see, it has a green roof, it has solar panels, so it's about mitigation, it's also about adaptation. And this adaptation float urbanization is considered to be one of the most resilient, because if it's too drought or too much water as flooding, you can see the infrastructure will move as well, like the floating pavilion as well. And tomorrow, Rutger Graaf will talk about floating urbanization. So just what I want to bring you, I have about 45 minutes, so it's quite long, but then again, also very short, of course, because this is a very comprehensive topic. I will talk about some of the challenges, so you know where we come from, the history of the Netherlands, then how to make resilient cities, and what kind of strategies you could use for that. And then when we have time, I will show you some tools that you can use, find your best management practices or something that relates to your climate span. Or I hope that in the future we do another climate cafe, which we already done a lot in Asia, as you can see on the map. We'll talk about it later. And I hope we have a great Q&A. So maybe to start off, like the history of the Netherlands, I think some of you have been to the Netherlands. I'm actually sure of some of the faces that I saw, but some might know that we live below sea level, the map that I showed before. As you can see, what is dark blue is prone to flooding. So it's below sea level or rivers will be flooding in those areas. So that's quite significant part of the country, about 2/3. So there are a couple of red arrows here that made Netherlands very prone to floodings. And one of them is the Afsluitdijk, we call it. It's basically a dike that made a part of the sea to a lake. Show this again. So this part is the Afsluitdijk. So this was all sea, and a lot of flooding is around when the sea came in. So we made this into a dike, also a connection from Holland to Friesland. And that is built actually constructed already in 1927. So that's a major construction of 32 kilometers of dike closing the sea, which, well, still is one of the engineering's high points around the world, so to say. And this is how it looks now. And it should stop these floodings, as you can see here, in 1960. So another year, what was a disaster for the Netherlands, 1953. Dikes broke in Zeeland, which is in the south. You can see here a lot of dike broke. Almost 2,000 people were killed. The sea coming in, of course, drowning a lot of people. So it was devastating. After that time, the Delta Works came in, and that Delta Works is a picture that you can see now. We closed basically a lot of things from the sea. A long time span, as you can see. It took about 50 years to do that. It's a lot of cost, a lot of planning, of course. And one of the highlights is maybe the Maasland barrier. If you have been to the Netherlands, interested in water, you probably see this. It's a lot of steel, as you can see. It's with doors like 210 meters wide, so it's really a mega structure. I think it's more impressive than the Eiffel Tower in Paris, but don't tell it. So, and at every slide, if you want to have more, there's some information too. So, are we safe with that from the sea? Well, actually not, because recent years, 2 years ago, we had floodings in the south. Rivers in Germany, Belgium went flooding a lot of cities. There was a high precipitation, over 100 millimeters a day, and that is how it looked in July. This is from Germany, but also in the Netherlands. You can see that there's a lot of devastation, and of course, a lot of questions are we safe? For every part of the Netherlands is flooding, as you can see now. So even in recent times, that's what I'm telling is it's very important to be safe from water, as you will relate to, of course, Asia. The Delta program is not a program that was finished after the Delta Works. We saw that, as I show now in the recent pictures, and of course there are more examples, extreme rainfall, floods, but also heat waves, climate change having more higher temperatures, for example, but also periods of drought and sea level rise for the future, and also urbanization, of course, will have devastating effects on our little country, and we should deal with it. And how we deal with that, what kind of strategy is in the Delta program, as you can see here. Because also IPCC report makes great graphics. It's about floods, heat, drought, nature. Also, of course, biodiversity declines a lot in cities. That can be a problem for our food production. There's so many challenges that we have to relate to in the urban dense area. We don't have a lot of space. We don't have a lot of budget. So there's a lot of things that we need to be doing. Then there's a lot of excuses not to, actually. But some of the disasters that I showed will show you the momentum that actually a lot of action has been occurring. So just a little closer look to the problems before jumping to measures. And I put 2 pictures there that will tell you that I'm very old. The cubic problem might relate to all of you. Basically saying that I love cats.
I'm sorry, Floris.
Yes.
Yeah, I think there's some problem with your voice over here, because we can clear to get your information. Can we play the video to?
Yes. If that is easier for you, yes.
Yeah.
Or is it better now, or?
Yeah, it's better now. It's more better.
Oh, shall we try that? Maybe my long beard was in the way. Okay, I try. If it's not, feel free to interact and we show the video.
Yeah, okay. We try to play your video. Thank you, Floris.
Okay, no worries. Yeah, I will stop sharing.
Hi everyone. Thank you so much for this invitation to present about recent technology on water management in the Netherlands for international knowledge exchange, of course. A lot of you are from Asia. I'm from Europe, the Netherlands. This is about knowledge exchange. You can see here in the first slide that it's about Asia and Europe, but also other countries. That we need to share our latest technologies and international knowledge exchange is a very important part of this. Maybe first I should introduce myself. I'm a professor in Groningen, which is in the northeast of the Netherlands. I'm also an affiliated researcher in also Groningen and Rotterdam, which is about global exchange of international knowledge on nature-based solutions, for example, and also a researcher at Deltares Research Institute, which is having projects all over the world. I have three jobs because research and practical practice and education is very important to combine, so we can share that knowledge between different stakeholders. So, if the dikes would break in the Netherlands, I would be underwater, which is, as you can see here in this slide, the dikes will break. A large part of the people live in the western part, and this will be flooded, as you can see here in this picture. So, just to take you, Deltares Research Institute, we do a lot of flood management. It's about sinking cities. It's about service and water quality and subsurface, soil, water, and good fresh water supplies, for example, or just some elements that are really about the environment and the infrastructure that we need in our cities and should be safe. I'm also a professor, as I mentioned, at Applied University. So a lot of projects that I will show you is about applied sciences. There's a lot of projects there. I just put this in that if you want to have more information, you can find it. My research group does a lot of projects around the world. And then the GCA, Global Center of Adaptation, what you can see here is about solution brokering of different nature-based solutions or whatever can help us fight climate change will be up there. And what you can see here is the first conclusion as well. It's really broad. It could be at cities, could be about rural areas. It's about locally led action, but also about water, disasters, finance. Of course, we need money, we need space. So it's a very complex world. I'm really about solutions, not about problems. We're going to talk about both. This is the headquarters of the Global Center of Adaptation in Rotterdam. It's a floating office with a green roof. It also has solar panels on top, so it's really an inclusive mitigation adaptation strategy, as you can see. And there's a lot of things you can find, like the floating pavilion. But next week, Rutger de Graaf, tomorrow Rutger de Graaf will talk about floating urbanization, so I'm not going to push that. But there's a lot of solutions that you can find. So, as I said, my presentation about recent technology. Next week, again. Tomorrow, Rutger de Graaf is going to be talking about floating construction. So I'm going to head off with some global challenges and solutions. I want to take you to the history, because I can talk about solutions in the Netherlands, but there's a whole history that we need to discuss before you will understand why we have these recent technologies. It's about resilient cities and strategies. And of course, I'm going to be talking about 45 minutes that I have time, and then we have questions. Could be even a bit shorter because I would like to have the interaction. I want to show you some tools that you can use if you want to have a more detailed descriptions of what I have. The two sites that you can use that we'll be talking on, and you have more information. I would really like to see what kind of questions you have. Maybe I can answer them. So just to start off, history of the Netherlands. I think some of you have been in the Netherlands. Other ones probably know of this very little country because it's below sea level. You can see here everything which is blue is prone to flooding. The sites that are under sea level, but also the rivers, as you can see here, can induce flooding in these areas. So, and especially from history, this was an open lake. We could have floodings here. You could have floodings from here as well, since it's open. And those were quite disasters that we had in the past that changed this country to a dike here. Which we will talk more about, and also the Delta Works, which is up here in Zeeland. And of course, the rivers have a lot of programs like Move the River. So the history of that dike that I just showed, 1916, severe floodings all around the lake, and it was easier to close that off with the Afsluitdijk, which is more than 40 kilometers long, and already completed in 1942. So it's quite an ancient work. At that time, it was quite challenging to do that, and that's why it's considered to be one of the construction. How do you call that? Prize-winning projects, or of that time. That's 1916. Another year which was very disastrous in the Netherlands was 1953. A big dikes break in the whole Zeeland. Almost 2,000 people died in this storm event. Dikes break, as you can see here. We just refought this event after being quite close in history still, because it changed the Netherlands. Because of the Delta Works we came after these disasters. We have barriers, as you can see here, large ones that we can close. It's quite an impressive structure, as you can see here. But there's structures all around to protect the Netherlands. You can see here in different years. That hasn't been done overnight, as you can see. In different years, we built a lot of defenses against the sea. And we are safe for now. We think we're not even at the top 100 of most dangerous cities. But then, so are we safe now with this Afsluitdijk and the Delta Works here? Well, not entirely. 2 years ago, we had severe floodings in this region, which you don't expect. But heavy rainfall can land down everywhere, as you can see here in the next pictures as well. Not only in the Netherlands, Belgium and Germany as well. Heavy rainfall. Locally more than 100 millimeters in a day, so you can see this devastation has been seen in this slide as well. So, just at the beginning, this is all leading up to the Delta Works, but also the Delta program, which is not only about the floods, which started with, but also the extreme rainfall, which could be anywhere. The heat waves, periods of drought, sea level rise in the future. We need a plan. And I'm going to talk about these strategies, and mostly also about the extreme rainfall and the floods in cities because of heavy rainfall or heat waves, because that is probably also near to everyone who's listening now. Of course, we don't all have the resources to make these big dams, and we decided to live below sea level. But I think if we rethink it, we might do different things in the cities. So IPCC report, probably you've heard of it or read it. It's about floods, it's about heat, it's about drought, but it's also about nature and of course our food resources like agriculture. We need to adapt. This is a scheme where everything would line up to see what we have to do, because it's about adaptation, but it's also about mitigation. But first, maybe look at some problems before we jump into different measures. If we talk about the Netherlands, but of course I'm talking about the whole world. We have more droughts, so more fires, for example, or infrastructure which is subsiding. You can see here the ground is subsided at this rate. So a lot of places with a lot of peat in the Netherlands are subsiding about 1 centimeter a year. which is in other places of the world as well. When you extract groundwater, peat will shrink, oxidize, and then you will get problems. Other problems with dikes. This is actually in 2003, a dike broke not because of too high water, but dry water, so drought. Instability of dikes can occur. So sometimes even in dry periods, we need to wetten the dikes to make them more stable. And then some pictures of the heat. Of course, temperature goes up. Global warming, which infrastructure has to be wet, otherwise bridges don't open. Or sometimes you put salt on asphalt so it won't melt. We have people that need to be cool, literally. So they sit in these small bathtubs. And heat, of course, is just one element. It's just one word, mostly an adaptation. But it's of course about infrastructure. You can see with the bridges, but it's also about train tracks and everything. And it also is about water quality. As you can see here, it's also about the livability. We cannot sleep. We are not productive. It's about open spaces. It's about health. So there are a lot of elements that need to be considered, as you can see here. And of course, flooding. Most drought or heat stress they call snipers. It's sometimes slow process, but sometimes they really get you in heat waves, for example. And flooding is everywhere. A lot of damage, as you can see here. High water, of course, all around the world. Some more examples in Amsterdam, for example, where you can see trains like boats to the city, or people, in this case, enjoying on an airbed going through the streets. But of course, a lot of vital infrastructure which is at risk. As in Amsterdam, this is a train station. So to sum up, there are quite some challenges that we have. Subsidence, damage to infrastructure because of drought. We have also the sea level rise, of course. We have floodings, water quality deterioration. We have droughts. So there's a lot going on in cities that we all need to address. It's not only about the water coming from the sea, where I started with. So because the whole weather pattern is changing. We have built a city. We have more runoff because we have more pavement. We have less groundwater recharge, so that could be inducing drought. We have less evapotranspiration because of the runoff and more grey buildings. So things change. And we have a heat island effect. In the middle of the city, it could be some degrees warmer than outside, and some degrees warmer could be the difference between livability or unlivability or even death. And then the Netherlands, it's a small country, but it's really diverse. We have peatlands, that's mostly where the subsidence is. A lot of regions in the world. We have saltwater intrusion. We're below sea level. So if you pump a lot of water out, the saltwater will come in and affecting our agriculture. We have a lot of urbanization, so a lot of urban areas popping up, you could say. And we have also sea level rise in the future. So there's a lot going on, as you can see. Sea level. This is under sea level, as you can see. This is the subsidence. Could go up to 60 centimeters in 100 years or even more at some locations. So that's really something to take care of. This is faster than sea level rise, for example. You can see that because cities are sinking. Rotterdam is one of them, but basically every city which is induced by subsidence under sea level. But also Indonesia and a lot of places that have sinking cities. And there are things that we do about it. Some examples already from Asia. This is in Semarang. For example, in the neighborhood of Semarang, this is the floating pavilion as we've seen before. This is Rutger speaking tomorrow. These are floating districts in Amsterdam, for example. So if sea level would rise or dikes would break, these houses would just go up with the tide, so to say. But of course, it's difficult to change our habits. And we still have cities, but we live in cultural history, so we're not going to abandon that. And we're going to build more because, well, in the Netherlands we have, for example, the refugees, they need houses, so there's a lot of building going on. It changes from natural natural infiltration and evapotranspiration. So basically, the climate model in the cities to more pavement, leading to more induced water in one place. So it could be flooding and also drought. And we're not very smart about it sometimes. You know, this is sealed, as you can see. Water cannot infiltrate. Trees don't get a lot of space in cities. You know, they're building. Green has to grasp for sunlight. So that could mean that we maybe have to build in another way, more nature-inclusive, nature-based solutions in cities. Because in the future, if we're below sea level, do we want to leave? Should we go to Germany or the higher parts of the Netherlands? Well, first we have to start with planning where we should build. And some places are very low, almost 8 meters below sea level, or we have gas mining in the north with tremors, earthquakes, so to say, which ask for not buildings. These are the rivers. You see Limburg, major floodings. Maybe we should do something else and not live close to the rivers. So there's a lot of debate on where should we build, because we have to choose our right locations to do so. So how will the Netherlands look in 50 years or 100 years? And there, as you can see, there are different visions from different organizations. Maybe we should go more floating, maybe we should retreat, maybe we should do things totally different, or even build more in the sea. There's a lot of debate about it. But still, to that time, we should be smart, making smart cities. Maybe not have green in one spot, because that will not do a lot for infiltration on other places which are totally green. That green line here and gray, we should have more room for green, and see if we can make this more nature-inclusive city. Because there are different kind of cities all around the world, of course, and some have totally no access to water supply or sanitation. Some are, we call them developed, but you could debate that as well. But basically have more natural cities with natural infiltration or evapotranspiration, for example. We have drained cities that are really about getting water out of the city as soon as possible. But it might be smarter to, have spawn cities, so to say. So basically, I will tell something more about that. But these are schemes, and you might want to have some more information. These could be considered as drained cities. These gully spots, it's really gray. You have stormwater, sewage, which is this is flooding in Groningen. You have one pipe that goes to the surface water here, and you can put a lot of gullies there. But this pipe will have the same discharge capacity, so will induce flooding. Basically like a bathtub, as you can see. So a drained city example. And as you know, probably some of these gully pots, they're quite fragile. It's only one point the water can access. So maybe we should do that in a different way. And that's how this artist would think of that. Because just one example to make it more lively, this was a major flooding in Beijing. The water is only on the road, not in the green. I think you know the answer. You need not to close up the water like with this threshold here. You should make it lower so the water can pass and maybe go to the green and infiltrate. Sometimes it's quite simple. So these artists make it more visible. The grass should be open. There could be a bioswale or rain garden. Promo pavement should be made. This is in Sweden. Let green again come in our cities. So here are some examples from around the world. I give you some time to sink that in. So we see green roofs, China, Madrid, Spain, one of the biggest green walls, great for biodiversity as well. Some artists made some musical instruments here in Dresden, in Germany. So when it rains, it will play a symphony. Or this is a biodiversity wall in Sweden. Quite big one, and some autarkic houses in Thailand, meaning that water cannot leave to be reused in those houses, for example. So these are some examples that we call nature-based solutions, small-scale nature-based solutions in cities. They deliver ecosystem services. They have a lot of benefits. Name some. So it could be, of course, biodiversity. It's a solution to fight drought, heat stress, cooling cities down, for example, storing the water. So it's about mitigation of floodings, and of course there's more livability. It could be even food production, or it could be isolation that we use less energy. So there's a lot of reasons that we could think of why green infrastructure should take over our cities more and more. So we have to protect the natural processes which the city was before, and get those processes back. So and that needs of course a lot of work. And in the Netherlands we already have been doing this for about I think we started in 1995 with bioswales, so grass fields that are a bit lower. You can see that in the beginning there was a lot of resistance. People would think, oh, the malaria mosquito will come back, or there's just a lot of mud. And then, we did a lot of research, and we wrote books, because that's what researchers do. And field trips, when a lot of people come over and see some of these first bioswales. And then we even have a Wadistraat, that's how a swale is called in the Netherlands. And that's an example in a lot of countries. In this case, Japan and Korea, for example. So we transported a lot of knowledge about this green infrastructure already in this time. So that's one example from the new technologies, which is not that new because it was already out there, but it's new that you put it in the center of urban cities, for example. So there are a lot of examples, and I'm not going to show them all. We should see what is, what makes sense for you in your situation, for example, and that will be my task to give you some tools where you can find these. Because there's so many measures. Over 100 which you can find in models, for example, tools, and you just have to know about it, because if you don't know it, you cannot apply it. So that's one of the things that we do. And one of those tools I'm going to talk a bit about later is Climate Scan. It has over 5,000 projects in the Netherlands that we can learn from. I do a lot of measurements also about these greening cities, and put up guidelines that could be useful for you. So, but most importantly, every city is different. We need a strategy, and a strategy is analyzing your area. It's finding your ambition. That's different wherever you are, even in cities in the Netherlands, but also, of course, on the world scale. And we have to come to action, and that's not that simple, because action is what you want, but there's a lot of policy and legislation and things that you need to come by with. We already showed these differences in cities that you could find. And also we have different access to analyzing. This is a 3D model of a city. We can actually fly through. It's quite advanced, but some you don't need all those models to know where your floodings are, or where it's too hot, or anything. It's finding an ambition. You have to do that together with all stakeholders in the city, and then you have to find action, and I will show you some examples of that. So mostly it starts with analyzing. These are different cities in the world that I worked with, that did modeling with, and also find mostly solutions for flooding, heat stress, and drought, but it's more wider, of course, what we have to do. A big example in Europe is Denmark, 2011, 150 millimeters in 2 days. A lot of damage, as you can see here in these pictures, and flooding as you've seen before, as you witnessed before, wherever you are, of course. And there's one strategy we have to do it together. As you can see here, we have these flood models, they're fine, we have these solutions, and basically you have to match problems to where you are. Because if you see a city, it's about buildings, it's about open spaces like squares, it's about roads, it's about green. And you can do a lot by buildings. And I've seen, showed you already some examples. Buildings could be green roofs, blue roofs, could be green walls. Squares could be water squares, which we'll show you later. It's about roads. Roads could be water storage as well. Roads could be floating roads, for example. And parks could be a major asset to fight climate change in cities. And well, sometimes I put here these links. So if you want more information, you can find that on online climate cafes that we do with several people around the world, interviewing them and see what made sense for them, how they would cope with different different approaches. So, co-benefits from blue-green, it's not only about mitigation, also about adaptation. And of course, it's about green, water reservations, about urban greening, which does a lot for both. Lower down temperatures. So, and also we are already too late. Adaptation, so we have to do. So there's less energy use, for example, and greening of cities. Maybe it's nice to show some examples. This is a lake where they put floating solar panels. It's 24 hectares. It's the largest outside of Asia. So in Groningen, in the Netherlands. And it looks like this. So this is a form, if it's too dry or too wet, it will just go up with the tide. So that's one example. This is a floating road in China. Cars can pass through this, in this case, nature reserve. But also, if it's too dry or too flooding, we can still pass. And this is not new. It's also near Jakarta. There are different places. And if you want to find it, it's all on Climate Scan. You can find who put up there more information on websites, pictures, and videos, and descriptions. So this is. I hope you can use this and benefit from that. So I was talking about small cities. Not very bright picture resolution, but these are some pictures from Singapore, Bishan Park, concrete, very gray, now made into a park, and there's much more room for water, for example. So that's also a small city where water can be infiltrated in this larger area, and it's beautiful to live there, for example, much more nicer than before. So a lot of green and good practices around. Here are some schematizations. I will just show you some pictures because that's a lot nicer. And sometimes it doesn't have to be, a lot of big work, but it could also be the no-regret solutions like gardening, very small. Here's simple green walls using climate plants, for example, so quite nice. This is some infiltration, which was a field, play field for children, for example. And here is a road which has no drainage stormwater system. It's a hollow road, so the water is actually guided by the road itself, which is an example. So then you can see some green roofs, and the new technology is actually green roof. You will know there's a solar panel on it, so the efficiency is a bit higher. You can also put plants on it, eatable plants, so it's also about food. And this is actually this roof you can adjust. You could adjust it by putting a valve. If there's too much water, you let it go before a stormwater event will come, for example, and then release the water to store more water or keep it in a drought period. So some examples. This is a great park on top of a roof, which we don't normally use, but multifunctional roofs for water storage. A lot of of these functions you can put to it. And also this is about mitigation and adaptation. So water squares, basically squares, low-lying squares. If it rains a lot, they can be flooded. As you can see in this picture. This is already was a square, so you can use it for it. It will stop flooding, and you can use it the water as well before drought. Some bioswales, quite simple. These were parked already. They made it into play fields, which is quite popular if there's water in it by kids, for example. So, quite simple. And as I said, we started already in 1995. These are some pictures of bioswales in 2001. This is in 2017. It looks the same. So of course you need to mow the grass. Sometimes it needs some adjustments, but they're quite sustainable, as they are called, sustainable urban drainage systems. Some more innovations. These are roundabouts. For some reason, most of the roundabouts are like a hill. But these are made hollow, so water can infiltrate, which has a very good function for water storage. Permeable pavement, make roads permeable, as you can see here. This is actually about the research about plugging, for example. But these are open, so water can infiltrate and infiltrate to the groundwater, which is great for example, drought, but also for flooding infiltration, inducing infiltration. So we do a lot of testing, as you can see here. These are some rain gardens in Arnhem. This is permeable pavement, and a lot of research which we can share in guidelines. So, but of course, happy. Great infrastructure, but of course there are challenges as well, barriers, as you could say. So there's some uncertainty about poor performance, which depends on how you would design it, how you will maintain it. So there are a lot of things. There are a lot of stakeholders. There's different planning than grain infrastructure, for example. The maintenance is quite a thing, and sometimes it costs more. So these are barriers. But of course, it's also about benefits. Benefits, financial, environmental, social. So there are a lot of reasons to green, as I saw in the beginning, because green infrastructure is an answer to most of these challenges that I showed before. And I was very happy to see also that it's taking over. This is in Jakarta. I'm not sure where exactly, but I found this on the website. It was quite interesting. I would love to do some testing in Jakarta and see what it does for the water balance in this case. So, well, I'm still on time, but I just want to show you some of these tools. I will go rapidly through this. You can find all these BMPs that I showed on climate.org. And if you want to know more about the efficiency of green infrastructure, it's about Climate Cafe. But we still have some time, so I will just brush through it. So this is climate.org. It's just a web-based. Everybody can put in their best management practices, which most of the people already done. As you can see here in South Africa, there's actually already an old map. It's over 10,000 projects now. It's about water, heat, it's about biodiversity. So you can go around. The floating houses in Samarang are here, or floating airports in Japan, rain gardens all over. The floating roads near Jakarta, you can find them all. So problems, but mostly about solutions. And solutions urban, small scale, but also the bigger picture as dikes and everything can be seen. Because really, in the Netherlands, but all around the world, everything's changing. So it's greening, and it's a very slow pace because of money. You have to plan it. People have to agree on it. So it's quite nice. Well, climate scan, maybe just go back. It makes sense to go to a platform which is near you. Asia Pacific gives you a lot of information. Climate scan is basically global, so it ticks a lot of boxes. What to say in this EU document? There are a lot of platforms, so you can try them all. This is one that you can be involved yourself. You can put projects on the list. This is a video, but I will change it. What's happening there? So this is because it makes more sense in for most of you in Bahasa. Probably so. There's also here Berantasai, is it called? This is mostly about water quality in Indonesia, but you can find a lot of projects there. It's a sister of Climate Scan, so that in your local knowledge you can share your projects, but they will come on the big database, so we can share them all. Contribute climate scan, so you can put projects on there if you like to. You can see it's already a lot more. Show all projects. If you put this is only projects with photos and descriptions. So it's a large database. It's open source, so it's free. It's citizen science. It includes everybody can participate. It's raising awareness. It's interdisciplinary. In some countries you can put layers to it as well. Like in the Netherlands, we have over 5,000 projects already. You can see what makes sense in green, or is it about biodiversity or drought. So there's a lot that you can add to for research as well. And what I like is that citizens put pictures on it as well, citizen science. And then you get these pictures of flooded swales. And sometimes we don't even know if these nature-based solutions work. And I love to see these pictures because this means it stores water, it infiltrates water. So it makes sense that we did it. Some people putting up pictures. You can see here getting in dangerous positions and sharing their knowledge, which is amazing. You can see here going off. I'd love to go in the field with Thomas, for example, what a lot of people do, and then we show them, and people are enthusiastic. This is the amount of projects they put on. High amounts, but enthusiasm, that's what it is. And if you would like to join, because it seems like a white male party, this is only a district, but especially there a vacancy if you are very enthusiastic about this work. And all around the world, there are quite a lot of people joining as well. My friend Nina, for example, from Surabaya, but also from other places where you can find a lot of projects around the world. So some user analytics, basically it's most regions of the world has been used. Male, female, balanced. In this case, more than 1,500 people are registered and ready to upload pictures or these projects, as you can see here. Water squares, flow plants, water purification, permal pavement, bioswales. Name in Dutch, name in English. Bahasa will be added to that as well. Some very famous projects like Bosco Verticale, the vertical forest in Milan, very green forest. This is my favorite in Belgium. Swales are mostly like ditches. They made it into a soup bowl, as you can see here. So it's amazing. You can sit around here, and still it's open that water could come in, and then you have a filled soup bowl. So nice bioswale. We've seen some of these already. These are rain gardens in Amsterdam South. Quite watched a lot, for example, so they're quite popular. And every year we see in Climate Scan what is most used. And this year it was permal pavement was quite popular. The years before it was rain gardens and bioswales. And the year before it was water squares, so you can see what kind of trends are out there. And these rain gardens are quite popular, especially if you put pictures in it when the water comes in and it just infiltrates and magically disappears. The magic of green infrastructure in cities, you could say. Because there's a lot of lately in the last years in the Netherlands, you could call this a new technology, rain gardens. The last years there were multiple are implemented to parking lots that the water would just go infiltrate here and there. So it's quite nice. One factor is of course time. They clock. One of the challenges with blue infrastructure, as you can see here. We do a lot of research in drought, for example. As you can see here, year is very dry, would it be the same infiltration capacity? Well, it does. Nature can recover quite fast. This is after a 7-year drought, and a day later it looked like this, and having a good infiltration capacity. Some moving pictures of thermal pavement, water square, bioswales, that research is really helping a lot of people around the world to see. Mostly we invite classes so they can learn from it. It's about capacity building as well, of also well-trained engineers that really want to see thermal pavement, how it works. In this case, it didn't work that well, so that's a very learning experience as well. And I have great talks with a lot of people around. So we do research, we calculate the infiltration capacity of these rain gardens. Rain gardens around the world, actually. This is in Bergen, Norway. This is in Gdansk. Of course, in the Netherlands, we do a lot of testing as well. We've been to New Orleans, Vancouver, so there are a lot of places. And it's very important to show that this is very effective. And again, if you want more information, there are some videos that you could use around it. So know that if you're a researcher, you find this very important. There's research files to it as well. Contact me. There's a lot of information more on these locations, because it's not only about hydraulics, of course. It's about user experience. It's about pollution rates as well, biodiversity. General, like how old is it? Where can I find more information? So the climate scan is a database. And the database allows you as well to see what can you do in an urban dense area like the center. What can you do in maybe a more newly housed area? So there's a lot that you could learn from, which is quite nice. And also in Asia, Africa, Europe, we did analyzing a lot what makes sense. So it's about urban characteristics in NBS. And every city is different. If you look at Johannesburg, it's really about drought. If you look at Malmo, it's more about green roofs. There's a green roof institute there. Rotterdam is very different than Amsterdam, so you can analyze with climate scan what kind of DNA you have. And I'm going to skip some parts and maybe show you where you can find also some information in climate cafes from Asia, and finish up there. Because we do climate cafes around the world. Well, what is a climate cafe? I, as a lot of other people, really learn if I see it, if I can be involved. Involve me and I will understand. So we do climate cafes with triple helix stakeholders, so water authorities, municipalities, but also companies, also a lot of different people, and we go to best management practices and learn about how they function in the field. So this is in Rotterdam, over 100 participants, and that was really about flood and drought and all the challenges that I just mentioned. This was in Coimbra. It's really about field education and showing them how you can change the climate, and that should be with a lot of enthusiasm. And in the field, green room, Malmo, bioswale. It's so fun to have classes in the field and seeing what you have to do, because then you can replicate and see what's out there. Climate cafes are not fixed. We did them in Asia as well. So sometimes about floating urbanization. It's about water quality, but mostly about climate challenges. It has to have tangible outputs. So we really make floating islands, for example. It should be interdisciplinary. So we learn from each other. It's not only about technical science, but also about social science. International, that's great because you learn from other cultures. It's about storytelling, social, and it's connected to open source tools. So and this is one in Canada, Vancouver, a totally different city than other cities. So every time you learn more, and being in the field with all these beautiful stakeholders, it was quite interdisciplinary and fun. As water quality in Surabaya, for example, we got on boats and sensors and learned a lot about how the water quality was deteriorated and what you could do about it. So cleaning wetlands, for example. In Samara, we had a lot of climate cafes interaction. Some pictures here about sinking cities, as I showed before, also about water quality and a lot of pollutions. So Does it have impact? Well, some of the climate cafes we published about, this is what you can learn online if you're a researcher, you want to know what the impact is, because that's every time it's different. But I really hope that sometimes we get more innovation, like these nature-based bus stop they call it. You know, it's made from hay, and there's a green roof on top. These are balls that made of circular from beer crates and garden chairs. This is maintenance done by sheep, which is not being done a lot in the urban area, but it's quite nice. I really hope we go from lawns to biodiversity, as you can see in the rain gardens and stuff. This is just fun, and we have to be critical on infrastructure and see how we could make it more climate adaptive. So finishing up, lessons learned, analyze ambition and action. I showed you flooding, but it's really about multidisciplinary approaches. We have experience. We saw there's lack of knowledge on green infrastructure, so we really have to raise awareness and capacity building. What we do mostly in climate cafes, for example. So it really needs behavior change, and I hope these examples that I showed are and inspiring to you, but mostly that you could see how it makes sense to your situation with engineers, planning, governance, and finance, cost and space. So I hope, and I'm not sure where your city is on this line, but we could leapfrog from maybe drained, mostly oriented flooded cities to more water-sensitive cities, which are an answer to drought, heat stress, biodiversity, and other problems that you have in your situation. So, and of course, you're never ready. You start here. You have to set the agenda. You have to make decisions. It's about implementation, also monitoring evaluation, but learn from it, and then implement what was right for your situation, and start again. So very important. Now, sum up. We share challenges. So let's share solutions. And I hope you contribute to Climate Scan or participate in a climate cafe so we can learn together from these new technologies, basically. And I hope these practical examples of resilient infrastructure is inspiring to you. You know where to find tools, information. You know where to find me. If I can help you, I would certainly help you out and to have more info. And I should probably stop here. And I hope you had a very inspiring and good time. And hope you have some questions that we can address too as well. Thank you again for inviting me and being able to share my knowledge and hope that you will share yours. Share your talent, move the world.
Okay, thank you, Mr. Floris. Sorry, Prof. Floris, could you hear us again?
Yes.
Okay.
Yeah, loud and clear. I hope the sound is better. Sorry about that, but I'm really glad we took a video.
Okay. Now, for all the participants, could you asking to the Professor Floris? Is there any question to Prof. Floris? Okay, Floris, maybe I can share my opinion, because there's a lot of problems with the water. In one side, we have a lot of waters. In the other side, we face with the drought. And it happened not also in the Netherlands, but especially in the tropical area, like Indonesia or Philippines, or mostly country in the Southeast Asia. So how we can deal with it? What kind of technology that you can suggest to us to deal with that? Because if we can adapt with that, maybe in the next 30 years or 40 years, we have a lot of problem with the water.
Yeah, absolutely. And well, of course, the continents are totally different. So Europe and Asia, as in rain patterns, but the solutions are still the same. it's important to have fresh water. That could be groundwater and also surface water. And you saw some examples of big lakes. So actually, we took some salt water from the sea and made it into a large lake, IJsselmeer in this case, which is our storage of fresh water that we use in very dry times. And that also relates, of course, to Asia and other continents. Only you have longer dry periods and you have very wet periods. So that's a bit of a difference, but then more technical solution comes in, and that's more real-time control. That means that if you have very wet periods, you already foresee that they are coming. You can release some storage water to sea if you have too much, for example, or keep it dry periods and have a higher tide, so you can go over the drought period. And that's then large-scale solutions. Of course, that's quite expensive. It needs a lot of infrastructure, but it's quite effective because you have a lot of meters that you can store and keep for drought or floodings. Then there's the small-scale solutions, which are all over the world now. So that's the rain gardens, that's the swales. And of course, that's storage just for short moments because it has to be empty, for example, in 2 days or 3 days. You don't want to have dengue or malaria or that kind of thing, so it has to be empty. But it all goes to the groundwater. And most cities severe from drought because of the groundwater levels we pump up because of drinking water, for example. But they go rapidly down, and you really have to put every drop that falls in a city should be infiltrating to the ground, or preferably maybe be reused, because now mostly we use drinking water, which is not sustainable for toilet flushing or other things. So reuse of water is quite a very big challenge in cities as well. So basically, my answer is to keep a more natural water balance as we did for the city. But now we are invading the city, say, for nature. So we should use nature-based solutions to solve these problems and really try to be sustainable with everything. So the water use should go down. We should have raising awareness because of the problems that everybody knows that you should not open the faucet for a long time, for example, and implement green infrastructure, which are multidisciplinary on drought, heat, biodiversity, also floodings, of course. So that would be my answer. And I really see some of these best management practices, so to say, in Asia, which is quite inspiring. I hope that answers your question or basically thought about the presentation.
Okay, thank you, Boris. There is a question from the participants. First question is, how to cope with these problems such as floods, damaged roads, and abrasion that occur throughout the country for greening. Also, how to be selective so that we are not wrong about going green, which doesn't cause global warming. And how to cope with about land subsidence.
Yeah, good question. Let me start maybe with the last thing, because subsidence, as you could see from my slides, is quite a thing. But it's worse here in Jakarta, for example. Some peat grounds, when you extract the water, mostly groundwater in this case, or surface water, it will oxidize. Basically, the ground goes down. There's only one way to stop that, and that's basically to keep it wet like it was. We tend to make it more dry, of course, for agricultural land or want to live there, but we should live with the water. And that's also the answer for your first question about the rivers. So basically, you don't want to change too much, because everything that we do as a human will will have a negative, sometimes also positive, negative effects like subsidence. We were on sea level, and now some of the points are -8. Of course, that's over 100 years, but that will happen in Asia as well if you do that. And Asia is not the only one. New Orleans is below sea level in the States, so it happens everywhere. So we really have to mitigate those effects. So keep it wet is one of our strategies in the Netherlands now. Keep it wet as possible. Then, of course, for floodings like in the rivers, there's more rules that you cannot build near rivers. Rivers need space. It needed space a long time ago, but now we just urbanized it, and we cannot expect that the flooding will stop. It's not only about climate change, it's also about our behavior of urban planning. If you build near the rivers, you should be aware that there's flooding, or you should build in a different way. So flooding homes, Raab is going to talk about good strategy, or amphibious homes that basically go to the ground when it's very dry and go up. So those are ways. There's a lot of examples around with basically ancient buildings are on poles because we think we're safe. If you flood, it's when you flood, basically. So I think, and the middle question about greening, yeah, we should be selective because there's a lot of lessons learned. If green infrastructure is new to you instead of gray infrastructure, it's totally different. So it functions different as well. And we should embrace the benefits. So also heat stress and other biodiversity. That's very important challenges in the urban area, besides, of course, drought and floodings. But I hope, and that's why I hope we share our knowledge, because rain garden in Jakarta is totally different than one in the Netherlands. It works the same, but the weather patterns are different. But most importantly, the governance is different. It still needs some maintenance on the vegetation. It still needs maybe a drain that might clog, and it should be ready to have benefit. So that's something that we can learn about. But then again, nature-based solutions are not rocket science. Nature should do the work, and it's easier than you think, and it's more cost-effective than we think as well. So I hope that answers your question a bit.
Okay, the next question is from Nick Naili Zukrina binti Nick Crosby. Earlier, you said that the river size in the Netherlands need to be enlarged. So how does this possible to be done?
Exactly. Yeah. It basically taps on my first answer of the last question, part two. One, the problem is that we narrow the river down, as you could see in Singapore as well, the Bisham Park or anything before and after. Enlarging means greening, sometimes removal of houses that are prone to flooding, but you can live in the water as well. If you know there's flooding, it's okay. You can be there, but you should be aware of it. In the Netherlands, we also gave land to the river again. So some of the polders are being prone to flooding. Still, sometimes people live there, but they know they get a warning, and then a whole polder is being flooded. And that's something really new in the Netherlands. We gain land from the sea and the water, but now we're actually doing something very differently. Make room for the rivers again. So that's quite a drastic method, but sometimes. And it's not that you cannot use the land anymore. It's still flooded maybe once every 10 years, so you can use it. You should know that it's too flooded. So living with the water, room for the rivers, those are two basically big programs in the Netherlands, which since if you look it up, there are a lot of examples how we actually did that. For the next time as well, I would say. So I hope that helps.
Okay, the question number 3 from the participant is from Christopher Jan Mendoza. Are there chances that the green infrastructure poses ecological imbalance since it has the capability of altering the biodiversity of the place?
Yeah, exactly. Sorry, I was reading another question, but yes. So indeed, most of our cities in the Netherlands, but also around the world, the ecological imbalance is quite severe. If you go back and see what changed, there's no ecology anymore. It's quite dead, you could say, and that's devastating. So implementing small gardens where birds come back, butterflies, but also the soil mobility, a lot of ecological in the soil, which is needed for infiltration, for example, should come back. And yeah, I showed you some examples of the bioswales and the rain gardens that take a lot of part of that. First, of course, keep green. Amsterdam has 37 parks. Are the last of our infrastructure of our capital. So that should be kept. Wear your hands from green, so to say, and implement green as far as possible. And that taps probably in the second question as well. What kind of challenges from Buddy is out there of integrated infrastructure? It's very hard to make room for green infrastructure in urban dense areas like Amsterdam, where I am now. So the parks could be multifunctional, maybe multifunctional. We flood parks, for example, because it's better to have flooded parks than flooded homes. So using existing infrastructure is very important. Sometimes a lot of cities use, how do you say that, some of the devastating events, disasters, like New Orleans in the States. Katrina was there in 1953, for example, but then in 2006, a lot of homes were broken. That is the time that when a home is flooded or flushed away, to think maybe we should not be at that place in the city. Maybe that place should be for green and water. Maybe nature is telling us something. So a lot of plots in New Orleans are now transformed for green. So that's a way to go about it as well. So it's all about urban planning, I would say. I hope that answers those two questions.
Okay. The next question is from Tiara Nor Andolia. Is there any challenge to integrate green infrastructure with blue infrastructure in Netherlands?
Yeah, green and blue. Basically, we call it mostly green and blue. It's about water. It's also about green. It's about blue infiltrate through green. So green blue solutions. There are some specific solutions, which is more like room for the river. Just talked about. Sometimes you also have not green roofs, but blue roofs. So that's only because water should be kept on the roof and can be reused for toilet flushing, or so it's basically stormwater harvesting. And there are some great examples in the Netherlands that it's only about one of the biggest blue structures on a roof is, for example, the tax department in the Netherlands in Apel. Great example. Not everybody is excited about paying taxes, but the roof is quite challenging because it could store up to, I think, half or 1 meter on that roof. So there are quite some examples that in small scale, blue is not integrated with green. Mostly it is a blue-green solution. And of course, you have the bigger blues, which are really about water. So it's room for the river. So I think those are, maybe that answers the question. And the challenges, of course, having room, having budget, and governance. So you have to know about these solutions, and that's why we have this course in this presentation. I hope that helps. Those are the three challenges with green.
Okay, maybe this is the last question because our time is running out. Are there any solutions that can be used for a short while as a countermeasure for the flood before fully going green?
Yeah, that's a good question because mostly being resilient is about exposure. It's about risk and vulnerability. But the strange thing is that some of these floodings occur once every 100 years or 10 years or anything. So we have to be flexible. We have to be maybe modular, that if something breaks, we can build it up quite fast. And that taps into, if you are in between strategies and the long-term strategy is something different than the short-term strategy, you should be flexible in the way, well, tomorrow Rutger Graaf is going to be floating urbanization. You can make existing floating, and then you can actually, with urban planning, you can move them, which is not possible with structure. I showed some of the floating roads to be an inspiration of changing strategies on the long run and being able to guide that. And then for green, also the nature-based solutions, it's not rocket science if you have a park and transform it to a green solution. Could be having other functions in the future. So I think changing from a drain city, as an example I showed, then to a more water-sensitive urban design city, it's all about being flexible. First, start with the core grids, being able to implement green is not expensive, for example. Those challenges can be addressed quite soon and can be reversible if you need another strategy on the long run. So I hope that answers that question as well. And there are indeed more questions. If we don't have time, you can send it by email and I will answer them also, of course. So because I understand that because of my sound, too much time as well.
Yeah.
Having to play the video. Yeah.
Okay. Our time is limited, so now it's 15:30 and in Indonesian time, national local time. And thank you for Mr. Flores to sharing knowledge about how to manage our water or how to manage the water in the Netherlands. And for the all participants, don't forget to visit climatescan.org to involve with the climate change. We know it can be more tough in the future, so your participation is more than everything to give a solution for our earth and our future. Thank you for the coming. Thank you for the join of the session. Good
Thank you so
afternoon
much.
for all.
All right.
Thank you for
Bye-bye.
this.
Thank you so much.
Thank you for Professor Forrest Bogart and moderator Mr. Ari Sentani for interesting presentation about water management. Now we will join the photo session. Please turn on your camera, all of participants. There's a photo session. Please turn on your camera. There's a 3 slide. Section 1. Okay. Next to the second slide. Yeah, please turn on the camera.
Is already screen soon?
And next, the last slide. Please turn on the camera.
Please.
Please. Okay, 1, 2, 3.
Okay.
Yeah.
That's enough.
Now we can believe that it is the end of our first day. I hope all of you learned something new today about Timbus Local Village, presented by Dr. Mila, and the liquefaction presented by Mr. Andreas, and the water management presented by Professor Flores. As a master ceremony today, we do apologize for our mistake to presenting our agenda today. Don't forget to rest well. We will see you on our next meeting of secondary RMI week 2023 tomorrow at 9 a.m. Jakarta time by Zoom meeting. Thank you for your attention. See you on our next meeting. Good afternoon, everyone.
Assalamualaikum
Wassalamualaikum warahmatullahi wabarakatuh.